Welcome to Cosmic Compass, where we journey together through the wonders of the universe. Today, we're exploring a strange but fascinating question. Can a moon have its own moon? At first, it sounds almost playful, like something from science fiction, but the physics behind it reveals surprising truths about gravity stability and the delicate balance of orbits. Let's dive in and uncover why moons are so rare and where the universe might be hiding one. Can a moon have a moon of its own? At first, the idea feels almost whimsical, like something from science fiction. Yet in theory, yes, it can happen. Strangely though, in our entire solar system, we don't see any moons with their own natural satellites. So why is that? Let's explore the physics, the challenges, and the rare exceptions that help us understand this curious question. The first thing to remember is that every object in the universe with mass has gravity. From the tiniest asteroid to the largest star, or even a black hole, each exerts a pull on its surroundings. But gravity is not absolute. It competes with the pulls of other bodies nearby. The region where an object's gravity dominates over all others is called its Hill sphere. Think of it as an invisible bubble of influence. Inside this bubble, smaller bodies are more strongly attracted to the object at the centre than to anything else. Earth, for example, has a Hill sphere about 1.5 million kilometres in radius. If you were anywhere inside this zone, Earth's pull would be stronger than the Sun's. The Sun itself has an enormous Hill sphere nearly 2 light years across, containing the entire solar system. In a sense, everything orbiting our star is within the Sun's gravitational bubble. So if planets can hold on to moons, why don't moons keep moons of their own? The problem is scale. Most moons orbit very close to their parent planet, so their Hill spheres are tiny. Take our own moon. Its Hill sphere extends only about 60,000 kilometres, a fraction of the 384,000 kilometres separating it from Earth. Within that small region, Earth's gravity still looms so large that it would easily destabilise any small object trying to orbit the moon. For moons of giant planets like Jupiter, the problem is even worse. Io, for example, has such a small Hill sphere that keeping a satellite is virtually impossible. In theory, a moon could capture or form a small companion, but the odds of that orbit remaining stable for long are very slim. There's another complication: tidal locking. Many moons in the solar system are tidally locked to their planets, meaning they always keep the same face turned toward their parent. Because of this, any small body orbiting them would experience tidal forces that slowly sap away its orbital energy. Over time, its orbit would decay until it eventually spiraled in and crashed. This process takes thousands or millions of years, but on astronomical scales that is still brief. If any of the moons we see today once had their own satellites, chances are they've long since collided and vanished. By contrast, planets themselves are not tidally locked to the Sun because they orbit at greater distances. That's why moons can orbit planets stably, but satellites around moons are far less likely to survive. Does this mean we will never see a moon with its own moon? Not entirely. There are unusual cases in the solar system where conditions allow something similar. Far from the major planets, asteroid 243. Ida spins quietly in the asteroid belt. It is only about 30 kilometres across, but in 1993 the Galileo spacecraft revealed a surprising sight: a tiny companion orbiting nearby. This little body, named Dactyl, measures just 1.5 kilometres wide and circles only 60 kilometres from Ida. We don't know how stable Dactyl's orbit truly is, but it proves the principle: even small bodies can, under the right circumstances, have their own satellites. In this case, it's not a moon with a moon, but an asteroid with a moonlet. Still a fascinating reminder of nature's creativity. So, can a moon have a moon? Theoretically, yes. Practically, the odds are stacked against it. Small Hill spheres, strong tidal forces, and the overpowering gravity of parent planets make it nearly impossible for moons to survive. in our solar system. But Ida and Dactyl show us that the universe still holds surprises, and perhaps somewhere out there, a true moon with its own moon is waiting to be discovered. After all, space has a way of defying our expectations. That brings us to the end of this journey. We've seen why moons struggle to keep their own satellites, how tidal forces and tiny hill spheres make it nearly impossible, and yet we've also discovered curious exceptions like Ida and Dactyl that remind us how unpredictable space can be. The universe is vast, and perhaps somewhere out there, a true moon with its own moon is waiting to be found. Until then, thank you for watching Cosmic Compass. If you enjoyed this exploration, don't forget to like, subscribe and share so we can keep discovering the cosmos together. See you in the next adventure.